Imagine you ask an AI assistant to clean up a small work mess. It reads a project note, it checks a calendar, it looks at a GitHub issue, it drafts a reply, maybe it creates a task for someone else. At first, that feels like a better chatbot. Then the shape of the work changes. The assistant is reaching into other systems. That is where MCP comes in. MCP stands for Model Context Protocol. The plain English version is simple. MCP gives AI apps a standard way to connect to tools and data. The human version is more useful. MCP is one way AI gets plugged into the systems where work happens. Once that plug exists, the important question becomes, what can this connection touch? Think of MCP like a standard port between an AI app and the outside world. On one side, you have the place where the assistant lives, ChatGPT, Claude, an IDE, an agent app, a workflow assistant, or an internal tool. On the other side, you have the places where work actually lives, files, calendars, email, GitHub, design tools, databases, customer systems, docs, search, billing, and all the small systems people forget about until they break. Before standards, every pairing needed custom wiring. This AI app needed one integration for that tool. Another app needed a different integration for the same tool. Every new connection became another little bridge to maintain. MCP gives those worlds a shared connection pattern. That is why builders care about it. For everybody else, the practical story is that tool access is getting easier to add, and easier tool access raises the value of permission design. Think about two connections. One lets the assistant search public documentation and summarize what it finds. Another lets the assistant read customer records, send email, and issue refunds. Both can arrive under the friendly label of tool use. One belongs near the bottom of the risk stack, the other needs brakes. You only need the basic shape. There is the AI app in MCP language, that is the host, the place where the assistant runs. There is an MCP server, that is the connector sitting in front of some real system. That connector can expose three kinds of things. Resources are things the assistant can read, like a file, a record, or a search result. Tools are actions the assistant can request, like searching a system, creating an issue, updating a record, sending a message, or running a command. Prompts are reusable task templates. They can guide a workflow, but the tools are what actually touch the outside system. For a normal person, the map compresses to this. Your AI app talks to a connector. The connector offers context to read and actions to request. That is powerful. It is also where the safety conversation begins. The first job is classification. Start with direction. Is the assistant only looking, or can it change something? A public documentation lookup only looks. Reading private files still only looks, even though the privacy stakes are higher. The line gets brighter when the assistant can change the workspace. A draft can wait in review. A sent email leaves the system. A merged pull request changes the code base. A refund changes the books. Those are all tool-shaped from the assistant's point of view. From a human point of view, risk rises with the thing that happens next. So when someone says, we connected this AI with MCP, pause on the connection itself. Did you give the assistant a window, a pencil, a mailbox, a delete key, a credit card? That one question turns the acronym back into a system you can reason about. Here's the ladder I would use. Lowest risk, public read. The assistant fetches public information or uses a side effect-free lookup. Next, private read. Now it can see files, emails, calendars, tickets, customer records, or internal documents. Next, write or draft. It can create or modify something, ideally inside a reviewable workspace. Next, external send. It can move information outside the chat, email, publish, comment, invite, notify, or handwork to someone else. Next, destructive action. It can remove something people may need later. Delete, overwrite, cancel, revoke, close, merge, or remove access. Highest risk, money moving. It can buy, refund, invoice, transfer, provision, paid infrastructure, or create a financial commitment. That ladder is the heart of this episode. MCP may provide the plug. The ladder tells you what kind of plug you are holding. A public lookup can run quickly. A refund, deletion, public message, or paid action needs a slower moment where the system shows its work. The more a tool can change the world outside the chat, the more visible the decision should become. The common failure is treating a connected tool like a trusted tool. If the assistant can see a button, people may assume it should press the button. That shortcut causes trouble. A connector only creates capability. Trust comes from the structure around it. Scope says exactly what the tool can access. Intent says what the user is trying to accomplish. Evidence shows what the assistant relied on. Confirmation gives a human control over the risky step. Logs preserve the trail when something goes wrong. If those pieces are missing, the connector may work perfectly while the workflow remains unfinished. Tool access also changes the prompt injection problem. Imagine an assistant reads a web page, an email, a support ticket, a document, or an issue comment. Inside that content, someone has written instructions meant to manipulate the assistant. If the assistant can answer only in chat, that is already a problem. If the assistant can call tools, the stakes move. Hostile or misleading text might try to make it leak data, send a message, change a record, or call a powerful tool at the wrong time. You can still connect tools, just treat outside text like outside text. Keep powerful tools narrow, validate inputs on the server side, require confirmation before irreversible actions. Show the human what will happen before it happens. Random text from the internet, an email, or a ticket should never drive the controls by itself. Human in the loop sounds comforting until you look at the screen the human actually gets. A real checkpoint helps the person decide. It names the proposed action, it shows the evidence, it identifies the system that will change. It says whether the step can be undone. It also gives real choices: approve, revise, cancel, or escalate. A weak checkpoint says, send invite. A stronger checkpoint says, send calendar invite to 3 external vendor addresses for Friday at 2 p.m. Attach the project brief. No customer data attached. Owner, Maya. Meeting can be canceled before send. Now the human can inspect the decision. The checkpoint has become part of the work instead of a decorative pause before the work happens. Picture a support workflow. The assistant can read customer tickets and order records. It can draft replies. It can recommend refunds. A customer writes, "My package never arrived." The assistant sees a delayed shipment and prepares a refund. That sounds reasonable, but there are 2 open tickets. One says the original package arrived damaged. The other says the replacement shipment is still in transit. Replacement refunds follow a different policy. The assistant looked at one record, missed the second ticket, and presented a weak approval screen. Refund recommended. The model made a bad recommendation, but the surrounding workflow let the recommendation travel too far. The refund tool was too broad, the evidence display was too thin, the checkpoint came too late, the logs showed the final click, not the reasoning path. MCP made the connection possible. System design decided how responsible that connection became. Here's the practical move. Pick one AI tool connection you already use or plan to use. Write 1 row for it. Name the system it connects to. Name the owner. Name the highest rung it can reach on the ladder. Then add 3 operational facts. First, where does approval happen? Second, what evidence is shown before the risky action? Third, where would you look if something went wrong? That row gives you a starting map. If the highest rung is public read, you may only need a light note and a basic log. If the highest rung is external send, destructive action, or money moving, pick one repair before you expand the workflow. Narrow the tool, move the checkpoint earlier, improve the evidence display, add the missing owner, tighten the log. A huge governance program can wait. You need one honest row, fixed in the right order. MCP is useful plumbing. It helps AI connect to the tools and contexts that make assistance genuinely useful, but the more normal it becomes to plug AI into work systems, the more normal it has to become to label each connection. Ask what got connected, ask what it can touch, ask what happens before it acts. Good plumbing still needs valves, labels, and shutoffs. That is the point of the permission conversation. If this helped untangle the system, hit like, subscribe, and follow Archive of Worlds for more field guides to the systems shaping work, money, tech, and everyday life. Keep the system human.